Yeah, myself, Harish. I'm working as a data architect. Uh, I've been having around 16 years of experience. So I've been working with the data almost throughout my tenure. So I've been started my career as a testing, data warehousing testing site. So gradually, I've been moved to different levels, ETL developer. Initially, they used to call it, which are on-prem tools. So then gradually moved into the cloud stack. So I've been working with different cloud stack and different projects. I've been having a rich experience. Majorly, the projects which I worked on is on Azure stack, but parallelly I've been gotten a opportunity to work with Snowflake as well, and even AWS as well. But my core competency is Azure and Databricks. Okay, it's all about my introduction.
This is Amit. Uh, I hope you can hear me.
Yeah, yes, I mean,
Yeah. So I have 19 years of experience in IT industry on the data background, and I worked on Azure Synapse, Informatica, mainframe, SaaS, and various technologies. So I have just returned from Australia, but I am interested in learning from you on the Databricks side. Uh, though I have been going through the online tutorials, but I think you have better experience in that field. So I would like to learn from you.
Amit, yeah. So you're already from data background, so it will be very easier to interact. Nice to hear. Okay, you're able to see my screen.
yes, now we are able to see.
Okay, okay. So let's start about what is the current trend is going on. So everybody knows artificial agents, AI agent, Gen AI, right? So right now the trend is this. Anybody having some quick uh, idea on that? What is that AI or generative AI? What it does? So let me take it over. Okay. So right now the current market or evolution might be not now over 2 years or 3 years. Everything will be most of the processes which is manually repetitive things are there. It will be automated using that. So using this where they'll be calling as an AI engineers in future. Not now over 2 years or 3 years. Okay. For that, what is the core thing is it's about a data. So they build certain kind of LLM models, machine learning capabilities, and all other stuff. And if you don't have proper data organized or properly prepared data or something, if you can't really provide it might not give that the expected results or something. It might it has to get trained or something. So the core crunch for this also data, oh, right? So wherever you see that artificial intelligence, you talk about ML, you talk data scientist, data science, or you talk about anything the core, it has been relying on the data level. So now the people understood the actual meaning of data, how important it is in current day to day, if you want to perform certain kind of activities or anything, they understood what is the core essential of data. So without data, you have a robustic program or something. Unless until you will not provide any data, how it is gonna process it or try to find out certain kind of analysis or pattern or certain kind of information. Even if you see the chat GPT or something, you do a prompt engineering or something, you try to key it. So backend, it goes to search the data and try to provide what are the output, but relay everything is on a data. Now the people understood what is the much importance of the data. Whatever the data is being originated from different systems, it could be through API code, or it could be like in any applications, or it could be IoT or anything. So how we can capitalize data, how best we can use it, if it is taking in retail. So initially it was there, doing a promotions or some kind of off, to generate offers, other things. How, where they used to identify, we have to do this promotions on certain areas or certain product level, certain category level. It's all based on the data analysis or whatever the things are there or something. It has been started, but it was right now the evolution is on more going around the data. So how you can process it, or how you can manage it out, how you can really work on that aspects, right? So even we'll see that migrations, data migrations, people want to do some one environment, other environment, might be there on Informatica, just they want to migrate it to the cloud environment. So data has to be migrated to this, to that, different databases. So wherever you see the about it, the fourth thing we talk about data. So that's where now the prominent in the market is for data engineers, or for data scientists, they hang a more demand in compared to any other technologies. There are things are there, but still, uh, now it is high demand for this area. Okay, so I'm not going to much details about it. Let me take little history about it. How the data things is been started, what are the stuff was there, what are the challenges. Then I will come back with the curriculum things. What are the things? I'll try to do that. Okay. So when this data evolution started, just suppose 1960. So here you see that even if you go back and look into that, how the systems looks in 1960 or something, it's very huge, very big missions to process very less data, and they used to manage it. Since the volume is less and small amount of data, it was managed in normal text files. Okay, so gradually in 1970s, they want little they want a data little organized in a structured way, they want it. Then the evolution started about spreadsheet. Okay, so these are where you have this, about it, actually spreadsheet, little organized, where you have to maintain the data, other stuff and everything. That was the evolution started in that. But gradually data started growing little bit, and even they want to organize, they want to query something, all other stuff. Then in 1990s, this RDBMS, relational database, databases, like it could be Oracle, Teradata, DB2, something, relational database, where you can have a structured query language where you can query and view the data, place it properly, organize the data, other stuff. So it was been started the evaluation on 1980s. Sorry, it is not 90s, it is 1980s. Just on RDBMS, I have front end application, I want to manage that application behind, I want to store the data, so I can have some database, relational database. Initially it was in a different way, they used to manage it out, but later the evaluation came, we can query it and we can manage it more effectively. That was the thing is started for storing the data. So then same thing, same stuff, things has been started, data getting increased and other stuff, and even they want to process the data and other stuff. So they want to in 1990s, the thing is called data warehouse. So where they started collecting all different I have 10 units, so each unit I'm maintaining one RDBMS level. So collecting all together, placing it to intern to want to process this other thing. It started with the concept called database. Where is this? This is simply nothing but the collection of RDBMS. So this is a structured. We used to do data analytics to some kind of if you are little on-prem background, we can see that warehouse builder, Informatica, data stage, different tools was there, even to perform the ETL other stuff, and to build for a data warehouse there was something data modeling. We used to prepare some data model, and what are the source systems are there. We have to bring it, and other stuff slowly started in 1990s. Okay. So in 1995, since the data evolution started from this, the things started growing. IT revolution is started. If you see that 1995 or 2000 side, it is it was a good phase for the IT thing. Where the evaluation started, the data started growing. The data was very huge. So that time, right now, we could see that we have a Spark, or we used to have initial before that MapReduce, or Hadoop ecosystem or something. In RDBMS side, that time it was the to process very fast, to handle huge data. There were certain limitations, but Teradata was used to be a pioneer in that area for parallel processing, other stuff and everything. But still, if you want to handle very huge data, see, in terms of if you see Google, Yahoo, or some other stuff, so the volume of data, the originates, or the way we have to process it, other things, it was very challenging. So in 1995, what it is started with, someone called Dong suggested something about we can process the data in small chunks of data, have 1 TB data, 1 TB data or something, 2 GB data or something. Let's divide that one into small chunks. Let me see. So I have a very huge data. So what is suggested? Let's break them into small parts. Different chunks you can process it. So if I have 1 GB, let's break into that and get it processed on different machines, which is nothing but a current terminology it is, and it's kind of a nodes we can talk about. Okay. So I have a huge data here. Very huge data. I want to process it. So even if you think about it, you have a 1 GB or 2 GB data to copy it from hard disk to pen drive. So how much time it will take us just to copy it? Right? So it will take some 5-10, depends upon your hardware configuration, other stuff. It will take 1 hour or something like that, right? So it depends. So to process that level of data, we need to have a very big infrastructure support is needed. It is not so easy to process such a big volume of data, to handle the data, to manage the data. I want to store it, I want to organize it, I want to process it, I want to generate some results. On top of it, that results I want to save it into different location, or there are plenty of operations I want to perform it, to do that. So this person came up let's divide this one into small, I'll make it into 3 parts. Just suppose I have some GB data or something. Then let them process it on different missions. This is set 1, set 2, and set. Just suppose right now it is different missions. It's just kind of a nodes. Okay. Then this is a main mission where it will be process. This is a mission which will take the results, other stuff and everything. But he provided a half solution only. Let's break the data and process it on a different thing. But there are the certain challenges was there, how we gonna, like, if I have a, like, I have a region wise data, like, this is south, west, north, east. So I have a different missions to process it. But how I gonna aggregate all these results if I want to see at a complete APAC level, or like, or if you take in India, like, country level, I want to see that. I have a state wise, I have a like, the data has been processed or something. But how I can combine that all results and I can produce it as a single output? That things was been not answered. What is the thing he told about it? Like, few things. One thing is about like, distributed. Second thing is suggested was distributed file system. Okay. Then third one he told about it. It will be an open source, so anybody can use it or something. But distributed file system is like, the way the like, if you see HDFS, which is started later point of time, like, where we try to replication factor wise, we'll try to maintain data blocks, and where we try to manage the data in a different nodes, right? So initial stuff, like, this Doug was instituted this DFS, but the DFS got failed because it was not able to do the aggregation. Like, they have find out the results, but they need to combine that result all together, and they want to provide it as a single output. That was, he was not able to answer it out. That capability was not there. Moreover, the aggregation was part was not there. Okay, so this got failed, which was like, way back in 1995 I'm talking, where nothing was be like, there is a known uh, like, this big data, that some kind of some other concepts, nothing was there. Okay, so this was the thing. It has been try to, like, initiated, like, how we can manage this big data, and but processing and aggregating the results, other stuff, it was not able to clarify, or like, the things didn't came up, so it got failed. But when take one more, into 2023, sorry, 2003, something Google has developed, which is GFS. It is same thing. It is been derived from the DFS, Google File System. Okay, where like, they, like, they said, like, we'll try to provide that kind of solution where we can aggregate these results as well. So what are the results are there? Sorry, this level results are there, right? So we'll try to aggregate these results, like, what are the like, select start from sales from Kolkata, or like, the West Bengal, or select like, some kind of what are the things are there. It will try to process it on each missions. Then this one I will, like, consolidate it and provide it as a single output to that one. So Google came up with that, like, that initial thing was like, Google file system, which has been moreover like, using this DFS concept itself, they started that one. Okay, and in 2004, this thing started, like, map reduce. So how, what are the things used to happen? So when you talk about a map reduce or something, so I have a chunks of data. I have one single query. Like, select sales from that particular region or something, or whatever this thing is there. So this query will be passed through each node, and it will generate certain results. Then this will used to get aggregated as in a one single result set and used to give it to the final node, where we can see the actual results. So in the when you see at the map reduce thing is oh, so it will try to map the query to the all the available nodes. Have a 10 nodes means it will try to map it that query to the 10 nodes. Then what it does, one. So it will try to reduce that what other stuff is there into one single result. That is how the map reducing is came into existence. In 2005, they developed one thing is came up Hadoop, which is nothing but for map reduce plus DFS. So this file system, what used to do, it used to store Yahoo, Google, or some they have a huge amount of data or something to manage, right? So they need to have a kind of a distributed file system, front end it looks like one framework and just you are storing, but back end it will be having a distributed across multiple nodes, it will be some clustered other stuff and all together. So in 2005, once the data has been stored, organized on a different nodes, it's been stored, and I want to query it, I want to do process on that particular data, which is a very large in amount. So how you gonna do that? For that things, when they started finding it out, these are the problems that are gonna come. This evolutionary Hadoop thing came into picture, where it started using MapReduce to process the data, DFS is to manage the data, where I can store using a MapReduce, I can perform the what are the activities. But it was everything was based on what are the MapReduce, everything is in a disk base. Means it will store when it has to process, it will try to know whenever it has to divide everything, it will be in a disk based processing. Okay, so the challenge was if the code was very complex, it has to require 3-4 iterations. I want to do sort, I want to do aggregation, on top of it I want to do filter. So it will try to have a 3 or 4 iterations for the transformations. So 4 times IO will be there. It has to read, it has to do the sorting on the multiple nodes, then it has to do aggregation, again one more iteration. There will be multiple iterations when we talk about a map reduce. That was when you have a complex code, very large data has to be do that, it will be a little complex thing. But another challenge was when we use a map reduce, we need to do a map code, plus we need to reduce the code. Reduce it means consolidating the results. Then we have to provide the code things to the main code where it will be processed. Then there will be something MR job which will execute, which is required it will convert into a jar file, and then we used to deploy. This much complexity was there when we use it a map reduce. And moreover, it was everything on a Java and other stuff. So it is not that easy, to really user friendly or something when things to handle or to develop or other stuff. It required the specific specialist in IT side or something to manage these things. But moreover, backend whatever we see that it is on a data level only it is going on. It was very huge, manage other stuff. These are the evolution started how we can manage other stuff. Might be different tools, stacks, and other things came. So everything is to process main core about a data. Okay, so in 2008, Facebook told you give SQL queries. Our code, what it does, it will convert into Java code and process it. So if you are little having a good knowledge on SQL or something, you write a queries, you learn the queries, So our thing will convert that one into the Java, and it will try to process it. You don't need to really learn about a Java other thing. That's where the Facebook has invented Hive. Then Yahoo invented the Pig, but it was not that popular compared to the Hive. Okay, now also we can see if you see the Cloudera other things. Okay, Hive Metastore will see in a Databricks. Now it has been removed. It might be a later point of time they might remove that. When you have individual workspaces, initially it used to have a Hive Metastore to manage the metadata. Okay, so since it's an open sources, everybody has to pick it up and started doing it. So these are the things started evaluating, and everything was bits and pieces in open sources. You have to do integrations, other stuff, and everything. So that way the things came up in 2009, where cloud era, where they started providing Hadoop plus Hive plus Scoop. They used to package it as an enterprise level solution. Okay, you don't need to really install and configure it and set up and everything. They used to provide as an enterprise level solution, so where you can just start using it out. They have a distributed file system, they have a SQL support, they have a Scoop, where you can do the data ingestion, other stuff and everything. They started it is not like with now we'll see Microsoft or AWS, or we talk about GCP or something. So it was in a 2009 cloud era. Hortonworks, other thing, people started getting into this very big data stuff, big data terminology, other things, where they started processing this very huge volume of data, other stuff. Because for a Facebook, Yahoo, right, how much data is getting originated every day and today, right? So the challenge was here. It was very, very slow when you have a complex and very large volume of data. It will process, but it was very slow when it has to process the large volume. Plus, there is no support for streaming. And there is no support for ML thing also. So you have to organize it, you have to properly set up the data, then you have to run through the ML operation. There was no direct support or something for the ML workflows as well that time. Then, so everything, it was here a disk-based processing, disk-based, physical disk, it will go and store it there. They used to process it again. It has to go to the another iteration there again. It will, so IO will be more high. So that's where the thing is started. In 2000, I think, okay, 2013, I think, the Spark evolution started. Everything will be processed in a memory. So processing in the disk level is comparatively processing in the memory, which is always 100% faster than, right? So that time the RAM and the other cost was high. I do agree, but processing in the disk, or processing in the same processing, I told, I have a 3 iterations, iteration 1, iteration 2, iteration 3. So everything is on a disk space. So instead of disk, if I replace this one with the RAM, so it will be very faster, right? So this is also will be processed in RAM. This is also processed in RAM. This is my distributed file system. Here also again, go and save it into the distributed file system. So that's where the Spark thing came, where they started providing the certain things, it is open source. Anybody can open source project, which is created by the Apache. Then second one, they said data processing was fast. Then sorry, this is not sufficient. Then what was the other thing was It supports ML and streaming data. So major issues, other stuff has been at least came to certain level, okay, we can start using it this we can depend on this stuff where it can support streaming, even data is organized and we can run through these things. Then these things took into serious turn, they started investing, people started looking into this, okay, this kind of things are there, rather than going to the traditional warehouse method or something or managing other stuff. It was challenging. So we have this Spark was, and it was very free of cost. Only the thing is you have to bear your infrastructure, you have to set up that, and this is will also support SQL queries, since it was high other stuff was there like Spark SQL. Okay, that other things they started providing. I'm not going into the Spark architecture details, other stuff. When I take it up into in interview level, they might sometimes might ask what is the difference between map, reduce and Spark, why we need to go for it. But right now they're not really looking into it, so even I don't think so these kind of questions will be posed. But I'm not going to any detail level. I'm just showcasing that what is the history about it, so that you can have some idea why we need to get into this stuff. Okay, might be little boring, but still we have to see So we have a Spark engine which can process the data, which other things. But to set up that level of infrastructure for any company, it was a very huge investment, right? So how you gonna do that? Even this one you want to set it up, or this one, everything is it is a new investment for the company. It has to get the very robust infrastructure in order to do this kind of stuff, right? So how we can do that? That time these people will came into picture: AWS, Azure, and GCP. This cloud providers came that we will provide infrastructure. Okay, you can set up these things and you can pay as you go. So we provide the infrastructure, you set up your thing, you can process it, you can manage it in data in our cloud level, you can do that. So that's where these things will came up. Later they started so whoever have developed the Spark, these people they started develop Databricks, okay, which took the Spark engine, which is very parallel distributed parallel processing engine. Plus they introduced notebooks. Okay, they combined these together Spark engine and notebooks, where ID kind of environment this is also one kind of a product, okay, which uses anything AWS or Azure or GCP as a PaaS. It's just product as a service. Initially it was okay, so they doesn't used to have that kind of infra or something. It's kind of just a product which will have a customized and optimized, not even I'm sorry to say, but it was an optimized Spark engine with the proper notebook, organizing other stuff and everything. Where you can just ingest the data, connect to anything, you can write through any code, Python or R, SQL or PySpark, anything. You can write it to your comfort level code, you can process it, and after that you can save it that one into a different formats or different locations altogether. So Databricks was so when you see that architectures, so wherever you used to see there for a data ingestion we need some kind of ingestion tools. For Azure, what we saw, there was something they started building ADF. This is for the data ingestion mainly, or orchestration. Okay, but so once the data has been getting into that your ADLS or Gen 2 or something, you have to process it, right? You want to do the data cleansing, you want to perform certain kind of business logics, other stuff. So if the data is very huge and the logics was very complex and you want to break down or something, so what they like, they started, Azure tied up with the Databricks, and there it came like, Azure Databricks thing. So whenever you use Azure, inside Azure you have a Azure Databricks or something, which is in a tie-up with the Azure Fabric. I'm sorry, Azure Databricks team, where they can like channel it. Like if you use my Databricks, Microsoft has to pay to the Azure Databricks. So there it is started Azure Databricks. There we used to do the processing. Then this is being done on 2016. Then the things is started. So now what has happened? If you see Databricks, if you see Snowflake, Azure, GCP, AWS, see how many? Because they understood the market is gonna be very huge. They started investing, and these people now started as in a one-way complete product. Where initially there was a no data ingestion support, right? So even if you want to like what are the PaaS environment or other stuff, like it used to connect or used to mount points and used to get the data and process it. No, they have like they worked on it. They are working as in a come with a single complete product where it can handle the data ingestion, where it can process, where it can have its own workflows, where you can orchestrate all the notebooks, how you want to execute what are the stuff, everything. Same thing. If you see here Snowflake, there also like it was initially it's a warehouse, cloud warehouse, just to store and manage, like you can run through some queries, like they have different architecture, like computation is separate, storage is separate to process that, but like they have a different architecture. Initially it was, but now they're also emerging as in a complete product. They have started having a snow park where you can run through snow pipes, okay, and plenty of things. Similarly, now if you take the Azure, they are also coming up. See, now they're paying Databricks some amount, right? Whenever they use, some companies they want to use process other thing. When they go for the Databricks, Microsoft has to pay that. So they realize it. Okay, now we'll have our own product, everything end to end with the Microsoft components altogether. Then the thing started now. Fabric, where is everything is Microsoft. You don't need to go for a Databricks notebooks also. They have Jupyter notebooks. They have a Power BI. They have a streaming support, ML, AI, everything. One single product, one single solution with all the capabilities. It's kind of a SaaS product they came. Even these people also trying for the, because when you use Snowflake, we have to go certain integrations. So I wanted to like perform certain integrations, means I need to depend majorly. I seen that some projects they use Airflow, and for storage other things they majorly they go for AWS or something, or somewhere like they read the data something. Later it will like backend it will be stored in AWS only. When we try to select that Snowflake like like when we go for like subscription, that right, it will ask which PaaS level you want to store with Azure or major it is
Uh, Harish, just a question over here on the fabric. May I ask?
let me finish this, then I'll take it up the questions, everything one shot. Okay, just few more things are there. Just give me 5 minutes, I'll wind it up, then I'll open a bridge for like we can talk about this fabric other stuff. Okay, this was very new. It is not even I think 1 year or something. So right now things are in slow phase, but future will be like will be a good competition over these three people. Okay, I'll take it up your questions. Sorry to. So even for GCP also we have AWS is like they're fine with their past, like everywhere, like infra is they have huge infra, right? So they are fine with, but still they are also having like Glue and AWS, but they didn't capitalize much. Even now, their Oracle started OCI. Okay, they realize it later point of time. Okay, if you go stick with the database level, then it will be a thing. They are good with the middleware other stuff area, but data side, like they started recently. But this is a dinosaurs, which is far ahead. So it might capitalize a lot of things, but they like might be little lag behind on AI aspects. They're working on it. I'm not telling they're not, but still, but this is ahead with AI integrations as well as Snowflake. They are little advanced level, but still, when I go with the Databricks, in case initial versions. So for data ingestion, again, I need to depend on ADF, or I need to use some kind of other stuff for data ingestions, processing. After storing, again, I need to use some cloud DB, like I need to go Synapse Analytics or Snowflake or some other stuff. So it's only used to be processing only, right? So this is also like just for storage. But this one, it is having storage, it is having SQLDB or Synapse. So they started like focusing on the marketing team, other stuff, or like the research team far ahead. Like they realized it, they understood like in future how the things will be there. So let's provide one single platform where everything will be available. I have a storage accounts, I have a processing engine, I can do what other stuff you wanted with respect to anything, with respect to the data, AI, something they started, and they have a complete stuff. So when these people has to reach to that level to Azure, it might take some time. I'm not telling like they might not, but each having its own their own specific qualities, which might not match it with the other cloud vendors. 100% I'll agree, but still this one is little far ahead when comparatively these things. So right now, current market trend it is happening data engineer, where they need to know ADF. ADF means ETL tool, like if you know Informatica or any other tool that are kind of a initially they used to call ETL tool. Now there is no term called ETL. It is just like data for data ingestion plus orchestration. Like you want to create a pipeline, you want to execute, you want to create some dependencies, other stuff all together. And I want to go like create one single pipeline where I can call some ADF data factory or data flow, then notebooks, something blah blah blah. I want to orchestrate other things. You need to have for processing. We need to know data bricks. So if I see that architectures also, just give me 1 second. I'm just going to that. See, if you see here, just suppose with respect to the Microsoft stack, okay. So I have a data in ADLS Gen 2, right? So I can connect to any data source. I can get the data into ADLS in different formats, Parquet, ORC. What are the format where it is more compressed and huge volume of data can be managed in a one storage location? Using the ADF factory, I can do the data ingestion and get it into, it's a kind of normally we call medallion architecture. We have bronze, silver, gold, or we can say curated or semantic layers, other stuff, everything also. So using any OLTP system, connecting to that, we have different connectors in ADF. Then we can getting into some kind of layer where you have actual data. Here, using Azure Data Factory, I can connect to this. I can transform the data. I can apply business rules. I can do DQ checks, data quality checks, other stuff under everything. I can prepare data and I can store it into one more storage account, means storage place where data has been actually ready to proper processing. Then that one again, like here might be I'll be doing all data quality, metadata, other stuff and everything. Here I can apply the business rules. After that, data is been available on here. So this data, whatever the gold layer it is available, either I can provide this one into data science team, or like I can store this one into Synapse, like in a warehouse or Snowflake or something, which analytics team can be utilize it. This is how the things will be there. Like, when we see the medallion architecture with ADF and Databricks level, this is how the simple architecture they used to follow it up, set up any kind of cloud level environment level. Later, Microsoft, what is it? They removed this, everything they integrated, and they brought it into the Fabric side. That is a different story. Later sessions, I will try to tell it. Okay, this is how the things will be there when you talk about something. So processing, doing ML, other stuff, and all together, Databricks can do that. ADF for data ingestion, and for the once we build the semantic layer, Power BI can take it off. Okay, so a lot of stuffs are there. Like, there was something evaluation scheme, like, something called data lake. Then there was warehouse. Then they came lake house architecture currently, which is pending now, and then Delta Lake. Okay, plenty of terminologies, plenty of things are there which I have to go in detail level when I talk about project or architecture, like, how the things will be there. This is just about one simple demo, how the data was there, how it has been initially it was been set up, data point of time, how the different things started originating, other stuff. I just want to help you to understand why it is this, right? So right now we are into this level right now. So what are the things is required for that? So first of all, you should understand what is the distributed file system. If you're not, still I'll try to help it out. What is that distributed file system? Okay, or HDFS. Then you should be knowing what is a Spark and its architecture, what other things are there, other stuff. Then what is a data lake? Then things comes into picture. What is a data lake? Why this came into the existence? Then data lake. Then data Python, or why we need this PySpark or something. Okay, where will be using Databricks? Where will be processing that? Okay, where will be using that? Then setting up a medallion architecture, processing other stuff and everything, like, to understand ADF as well. So what are the transformations, activities we can perform? We can do it everything in ADF itself. Okay, Azure Data Factory. So this is so when you so these are the stuff, like, you need to understand how the things are there, like, so for any data engineering thing is SQL. If you know SQL, you have to, like, little understanding about what is the PySpark, how it is a small course will be written, or a Spark content. Sudden, like, you need to know this architecture, how the things will work, how you can other stuff. If you know little good with SQL, other stuff, you can use PySpark or Spark SQL, or certain kind of utilities are there which you can use it and can perform the data engineering. So these are the things which will be, like, I'll be covering it up as a part of data engineering thing, where I'll be covering complete Databricks things, like, right now what are the things are coming up with the new features, how to create an account, what other features are available. But before that, I need to cover all this stuff, so that where I can showcase it in practically here, why Delta things came into the picture, what is the cataloging, what is the Hive, how the data governance thing is being managed, and how the current projects things are happening. Certain kind of sample projects, 1-2 projects I'll be helping on to do that, like, some practice sessions, and I'll be sharing some code which every day we practice, and you'll have some recordings as well. So these are the things are there. So this is all about this stuff. So these are the things we'll be covering as a part of data. I didn't had that slide actually. I'll share it after this session or something sometime later with the detailed content. What are the things will be covered as part of my training? So I'll be covering this Databricks as well as the Azure, stack, little Azure and services as well as the ADF part. So I'll just open the forum for queries. You can start. Anybody can have any questions. You can start shooting it. Yeah.
Harish, this is Amit. Can you hear me?
Yeah. Go ahead.
Okay. So I have already installed Azure and Databricks on my laptop.
Mm-hmm.
Just I want to know that both are ETL tools. Is that correct?
Yes.
Okay. So why one should go for Databricks and not for ADF?
Okay. Give me 1 second. I'll log in and let you get you. So initially the ADF has been set up like SSIS.
Yeah, I have been kind of. I was working on a couple of folks in Australia, so I know something about SSIS.
Mm-hmm. So from there only it has been derived this one, ADF thing. Okay.
Okay.
So why Databricks in the sense it offers more advanced data transformation capabilities, it's having a Spark, right? So in ADF initially it was 8 node cluster, which is doesn't have scale up other things it is having some limitations over it. Okay.
Okay.
And moreover it is GUI based, right? So what are the things other you can drag and drop and do certain same how you do it in ODA or informatica level where you have a source qualifier or transformations, you create a mapping, other stuff and everything also. So it doesn't have so.
Okay.
But I'm good with it. If I'm good with some Python, so I can write that I just need to ingest the data here. Okay, so get one notebook here. I can connect it and I can have the support of these languages. If I'm good with the Python, I'll connect with the data and I'll do my coding in a Python. If I'm good with SQL, I can good with Scala and R. Moreover, it gives the streaming support. There also we have again we have to integrate with some different services. But in ADF again we have to event hub other things we have to do that, right? So here it will be, they made it very simplified, very optimized, and they used to give us some kind of compute and where you can choose which kind of cluster you can do the scale up. Plenty of additional features was there. So if the logic is very complex and it has to be very huge, data has to be managed. Moreover, once the data has been ingested and kept it in here after processing it, I can directly publish it for to run the ML operations, other stuff. So I don't need to really depend on integrate with some other things or to bring it up around. I can directly run through that ML ops or ML workflows, everything. So a lot of additional capability features was there. Moreover, is the advantage was about using a Spark. Okay. So
Yeah.
it was initially it was designed only for the data integration and orchestration, just to want to create a workflow with a user-friendly drag and drop. It was not that high robustic support was there. So what initially projects also how it has been built. Okay, but to do the data ingestion, I can use ADF. But processing my data and managing it, I can do through the Databricks. But storage, I can use it anywhere. I can store it in Synapse, I can store it in Snowflake, or I can store it in anywhere. That is not a problem. Ingestion, storing is not a problem. But processing, they started using the Databricks. It was very user friendly and having a multi-language support, optimized part, and you have a you can take a less volume of data. You can use when you go for the compute, you can choose your job cluster, small, medium, and you can choose what are the stuff job clusters, plenty of options they have provided. Very large, I can use a high configured cluster. If it is a small one, why I need to go ahead for that? Paying huge for processing small data when I go with it's all based on a pay as you go on infrastructure, right? So that is the main differences which we feel.
On the Snowflake side,
Mm-hmm.
if may I ask you a question?
Yeah.
The Snowflake side, it's a star schema which is has been expanded.
Mm-hmm.
But is Snowflake having a particular programming because it's just a database?
Yeah, right now that was I told, right? Snowpark is there where you can write your Python codes now.
So you are asking, like SQL, PLSQL is there, right? In Oracle, like that. You are asking, is there is any programming languages which are supported in Snowflake, right?
So I have been dealing with SQL from 19 years.
Okay.
Okay,
Yeah.
whether it is Teradata, Oracle, DB2,
Okay.
any language.
Yeah. Tell me.
But for Snowflake,
Yeah.
I just wanted to understand,
Mhm.
is there any programming language, whether it is T-SQL or whether it is what that needs to be taken care of?
Actually, straightly coming to that answer means there is no programming languages are which are related to Snowflake. Snowflake is, as you told, it's a kind of a cloud-based data warehouse. That's all. But once if you are having the data on top of that, we can integrate n number of tools, like you said, right? So Python, there's a Snowpark is there. Even in that Snowflake itself, we can write n number of PL/SQL programs. It support JavaScript. It supports even SQL also. There are a lot of Java. There are a lot of languages are available. Within that language, using that language, we can write any kind of programs like PLSQL.
Okay, okay. I understand that.
No.
So thanks for your inputs
Okay. Yeah.
and really appreciate it.
Yeah. Thank you, Aman. No problem.
Thanks, Harish. I like the way you are explaining. I have a couple of questions. The first question is, how many sessions you will take for this entire course?
Okay.
And
Yeah, we have planned to cover the sessions up to 20 to 25 sessions. We have planned to cover.
okay. And are you going to cover Fabric or Synapse as part of this training, or
No,
just
no,
until?
Yeah.
no. Just
No.
the ADF Azure level. What are the services we'll be using it out as part of data engineering, and moved on Databricks level, how we can do that. I started with architecture, other things Spark, other stuff. Then I'll go into the Databricks features. What are the things we can do that? How this data evaluation came into picture, other stuff, and all together. After that, same capabilities, how you can do it in ADF. Later, we'll do some projects batch processing and streaming. Some POC projects, I'll try to help it on that, and we can do an end-to-end one project. That's how the plan was there. The Fabric, other things are just for how the things are getting evaluated now. The AI agents, other stuff to have some current trend, what is going on. It should not be like that. But still, for data engineering, always the market is very good. And so sorry. This was the things I'll be covering it out, but it's a very right now I think even Amit can accept how the data engineering projects are going on and how much the requirement is there for the resources who's working as a data engineer. The very huge market going ahead, plenty of opportunities are ahead. But you should be aligned with the data engineering